Let's go into more details about AWS Lambda on how to create layers, how to manage Lambda function versions and aliases. So let's create another Lambda function for this session and let's give it a name. I will choose runtime as Python 3.7. And for the role, I will choose existing one, which we used in the previous session. All right, let's create the function. Okay, before we jump onto layers and versions, let's spend a couple of minutes on the Lambda function inputs. We already had a glance in the previous session. Let's see what they are and how you can use them in your Lambda functions. So event is basically an object which contains the information about the triggering event, say an S3 put event object or a DynamoDB stream event, etc. It is basically a key value pair. If your runtime is Java, then it's usually a bean or a pojo. And if your runtime is Python, then it's a dictionary. And if your runtime is Node.js, then event is a JSON object. You can find sample events in AWS documentation. You can go to Google and look for AWS Lambda events, and you will be able to find out this particular documentation from AWS. For example, this is how an elastic load balancer event looks like. And here is an S3 put object event. And this is how an SNS event looks like when you add Lambda as an endpoint for SNS topic. So you can use the event object to find out details about the triggering event and perform required business logic within your Lambda function. And next is context object, which provides methods and properties that provide information about the invocation, function, and execution environment. For example, you can run get remaining time in millis method to find out the number of milliseconds left before the execution times out. Or you can use this context.memory limit in MB to find out memory configured on the function. All right, I'm trying to print the event and the context method and the property from this Lambda function. So let's quickly run the function and see what it prints. And before that, let's modify the memory and the execution time so that we can see if the printed values are correct. Let's set the time to some 2 minutes and set memory to 1408 MB. That's a random value I picked. So let's save and hit test. So for us, in order to test from this console, we need to configure a test event. So let's quickly configure the test event. And let's hit test. There you go. Our test event has been printed and it printed the milliseconds remaining and the memory we had just set. So for complete list of methods and properties for the context object, you can visit the documentation. Here are the list of context properties you can use in the Lambda function. Although this says Python, the properties and the methods for the context objects would be the same for all the runtimes. All right, enough about the event and context object. Now let's talk about Lambda layers. These layers are relatively new in Lambdas. It was released in 2018. So if you remember this diagram from our previous session, the compute for Lambda is provisioned and managed by AWS, and we as customers has no control over it. So this compute is basically Amazon Linux 2 AMI, and it contains only certain dependent packages such as AWS SDK or certain JSON packages to play around with. And if we need additional third-party packages to be used in our code, let's say use MySQL connector in Python or Node.js to connect to your database and fetch some records, you have to install and package the dependencies within your function code. Now this will be a tedious job and it makes your package bigger and prone to errors. Instead, you can package out the dependencies and add them as layers so that you can use them in multiple Lambda functions. Another use case, if you have to write a lot of Lambda functions And you have certain utility code snippets which needs to be used across multiple Lambda functions. You can simply package the utility code and create a layer, and you can then start calling the code from multiple Lambda functions. So let's go back to our Lambda function and see how we can create a layer and use it. So from the Lambda function, you can click on layers here and you can add any available layer. We don't have any yet, so let's create one. You can list and create layers from here. So before we create the layer from this console, we first need to have the package we need to use, right? So for this demo, let's create a small Python code which can be used from multiple Lambda functions. For Python, we need to have our code or dependent package within a folder named Python. So let's create this folder. And within that folder, let's create a Python file. And let's say name it as demolayer.py. And let me open this Python file. And let's add a method in it. Let's say name it as add. A simple method which takes two numbers and returns the sum of those two. That's it. Okay, we have the method ready and we would like to consume this method from our Lambda function, maybe more than one function. So let's generate a zip file at Python folder and give it a name. Now let's go back to the Lambda console and let's create a new layer. Let's give it a name. And in here, you can either directly upload a zip file or serve the zip file from S3 location. Since we already have the zip file ready, let's directly upload it. And we need to choose the compatible runtimes in here, which we would like our packages or code to run on. I will provide some random value under license in here. And let's click on create. All right, let's go back to our Lambda function. And let's click on layers in here. If you scroll down and let's click on add layer in here. So there are certain predefined layers provided by AWS. So you can choose from them, or you can choose the layers which you created from here and the version. So whenever you need to change the layer code, you need to create a version from the existing layer and AWS will automatically add a new version. But in the Lambda function, you need to update the version as well. It will not reflect automatically. So you would have to delete the existing layer and add the new version. Remember, this is layer version. We will be talking about Lambda version shortly, so don't get confused with that. All right, let's add the layer and let's save our Lambda function. Now in our code, we simply need to import the required package. In this case, the name of the Python package, which is nothing but the Python file named demo layer. And now we can start calling the methods whatever you provided in this package. So let's call the method by passing a couple of arguments, let's say 1 and 2. And let's print the result. All right, let's save the function and hit test. There it is. It printed the text from the layer method and resulted the sum of two numbers. Well, this is a simple demonstration of how you can use layers. You can try it out yourself with different use cases. Okay, next, let's talk about Lambda versions and how they can be effectively used with production deployments. If you're trying out Lambdas for testing purposes, or you developed a Lambda function that mostly does not require changes in future, you would not probably need versioning and may not have thought about it. But imagine you're using Lambda heavily, let's say, for your serverless web application or as part of microservices in your APIs, you need to frequently change Lambda codes in development mode without affecting your staging or production applications, right? This is where Lambda versioning will come into picture. By using versioning, you can manage your in production function code in AWS Lambda in a better way. So, with versioning, you can publish one or more versions of your Lambda function. As a result, you can work with different variations of your Lambda function in your development workflow, such as development, staging, or production, etc. Each Lambda function version has a unique ARN. After you publish a version, it cannot be changed. So let's see how the versioning works. I will remove these print statements and let's add a print statement, release 1, and let's save the function. Now let's go to actions in here and click on publish a new version. Let's give some description and click on publish. Now we have version 1. And by the way, these version numbers are not controlled by us. They are automatically assigned by AWS. So we have no control over it. And you can see here, code is only editable in the latest version and it's read only in the version 1. And if I scroll further down, see none of the configurations are editable. That means this version is read only and fixed. And we have a unique ARN for each version. Let's say you assume this as a staging or a production code. You can then share this ARN with the triggering applications, and they can keep calling this function with you making some changes to the latest version of the code, which does not affect this version. So let's try to invoke this function version from CLI. Before that, let me create a simple JSON to send as event. Let me add a couple of keys to this JSON, name and description. All right, let's save this file and I will go to command prompt. And the command to invoke the Lambda function is AWS Lambda, and then invoke is the action, and then the function name. Let's grab the function version ARN from the console and paste it in here. And payload as the input JSON file. We need to provide this as a file URL. And finally, an output file to which a response will be written to. All right, let's run this command. Command was successful and you can see the executed version is 1. And let's go back to the Lambda function and to the monitoring and view the Cloudwatch logs from here. You can see there is a log stream for the version 1. And if I open it, you can see our version 1 has been invoked with release 1 as a printed text. And if I go back to the code, you can switch versions from here. So let's choose latest, which is editable. And let's go to our function code. Let's say change this printed text to release latest. All right, let's save the function. And let's quickly go back to the command prompt. And let's execute this invoke again, but this time without the version. So if you invoke the function ARN without any version info, it invokes the latest version. So let's execute the command and see. And there it is. You can see the executed version is now latest. So let's go back to the Lambda function. And let's quickly change the code to as, let's say, release 2. And let's save the function. And now let's release a new version for release 2. And let's publish it. And our second version has been created. Now let's quickly go to the terminal and execute the invoke command, but this time for version 2. And there it is. You can see the executed version is now 2. And if we go back to the Cloudwatch logs, and there is a new stream for version 2. And our latest code changes are reflecting in version 2 with this printed text as release 2. Now look at this. Version 1 will still have the old code and version 2 has the latest code. Now imagine you shared your version 1 ARN as production version with 10 different triggering applications, and now you want to release a latest version as version 2 with some changes to it. Now all the 10 applications has to change the ARN to version 2 in their application. Otherwise, with the version 1 ARN, they would be hitting the old code and they cannot have the new changes. Now that's tedious for all the applications to change the ARN every time when you make changes, isn't it? This is where Lambda aliases come into picture. Now let's go back to the Lambda function, and under actions, you can create an alias from here. So let's create one and let's give it a name, say prod, and you can point the alias to a specific version. So let's point to 2 this time. You can also choose an additional version and shift traffic between these two versions based on weights. But for the demo, let me only choose a single version, which is 2. And let's click on create. So the Lambda aliases as well will have its own ARN. So let's go back to the terminal and let's invoke the prod ARN this time. And here is the result. It executed version 2, which we pointed to. Now let's say we want to make some changes to the code. Let's switch to the latest version. And let's go to the code. And let's change this print statement. Let's say release 3. And let's save the code. And let's go to actions and publish a new version. Let's say for release 3 and click on publish. Now let's assume we have distributed the alias ARN to all the triggering applications, and we want this release 3 changes to be reflecting for all the triggering applications. What do you think? It gets reflected? Not yet. So if you look at our prod alias, it is still pointing to version 2. So we have to manually update the alias to point to version 3. As of today, there is no way in the console we can update the alias to version 3 or whatever latest version we have. We need to do that through CLI. So let's go to the terminal and let's run this command. AWS Lambda update alias, then the function name, just the name of the function without ARN, and the function version to the version which we need to update the alias, which is 3 in our case, and then the name with the name of the alias, prod in our case. So let's execute this command. All right, the alias has been updated. Now if we go back to the Lambda function and hit refresh, and if we check the alias now, there it is. Prod alias is now pointing to version 3. And now if we execute the same invoke command with prod ARN without changing anything, and there it is, the executed version is now 3 with all the latest changes. And if we quickly go back to our Cloudwatch logs, you can see the version 3 stream is created. And if we open it, there is our latest code changes getting reflected. With aliases, you can keep all the changes transparent to the triggering applications, and you can seamlessly release your changes without affecting them. All right, that is it about some of the advanced features in AWS Lambda. Well, Lambda is an exciting service. It serves a lot of purposes, simplifies a lot of use cases, and makes coding fun. I suggest you get your hands dirty by playing around with Lambda as much as you can. Well, if you're worrying about the pricing for the Lambda, unlike an EC2 instance, you're only charged as long as the Lambda function runs. It's cheap, effective, and serves many different use cases. And it's an essential component in AWS ecosystem if you wish to be a developer on AWS platform. Hope you enjoyed this lecture.